This is the 8th video of the section, Estimating Housing Prices. In the previous video we looked at the polynomial regressor. In this video we'd solve a real-world problem using regression. It's time to apply our knowledge to a real-world problem. Let's apply all these principles to estimate the housing prices. This is one of the most popular examples that is used to understand regression, and it serves as a good entry point. This is intuitive and relatable, hence making it easier to understand concepts before we perform more complex things in machine learning. We will use a decision tree regressor with AdaBoost to solve this problem. A decision tree is a tree where each node makes a simple decision that contributes to the final output. The leaf nodes represent the output values, and the branches represent the intermediate decisions that were made, based on input features. AdaBoost stands for adaptive boosting, and this is a technique that is used to boost the accuracy of the results from another system. This combines the outputs from different versions of the algorithms, called weak learners, using a weighted summation to get the final output. The information that's collected at each stage of the AdaBoost algorithm is fed back into the system so that the learners at the latter stages focus on training samples that are difficult to classify. This is the way it increases the accuracy of the system. Using AdaBoost, we fit a regressor on the dataset. We compute the error and then fit the regressor on the same dataset again, based on this error estimate. We can think of this as fine-tuning of the regressor until the desired accuracy is achieved. You are given a dataset that contains various parameters that affect the price of a house. Our goal is to estimate the relationship between these parameters and the house price so that we can use this to estimate the price given unknown input parameters. Let's see how we can do this. We'd have to create a new file called housing.py, and we need to import these files and modules. There is a standard housing dataset that people tend to use to get started with machine learning. You can download at this link. The good thing is that scikit-learn provides a function to directly load this dataset. Each data point has 13 parameters that affect the price of the house. You can access the input data using housing_data.data and the corresponding price using housing_data.target. Let's separate this into input and output. To make this independent of the ordering of the data, let's shuffle it as well. This is the code to shuffle the data. The random_date parameter controls how we shuffle the data so that we can have reproducible results. Let's divide the data into training and testing. We'll allocate 80% for training and 20% for testing. We're now ready to fit a decision tree regression model. Let's pick a tree with a maximum depth of 4, which means we are not letting the tree become arbitrarily deep. Let's also fit a decision tree regression model with AdaBoost. This will help us compare the results and see how AdaBoost really boosts the performance of a decision tree regressor. So let's evaluate the performance of decision tree regressor. And then we evaluate the performance of AdaBoost. Now we'll check the output. We can see the error is lower and the variance score is closer to 1 when we use AdaBoost. Great! So in this video we applied the regression principles in order to estimate house prices. In the next video, we'll take a look at how important the features are and how to compute their relative importance.